So we'll discuss about the tracer techniques in groundwater and hydrological cycle. So first we'll discuss about what is a tracer. We call a tracer a substance that is used to trace the course of a physical or a chemical, biological or the geological process. So if you see here, people are adding the tracers to identify the groundwater flow and all, and also the surface water flow. It is something like a sensing element or also a monitor device or such a monitor which can be used for identifying the dynamic process such as circulation of the blood flow in the animals or circulation of water in the hydrological cycle. So the use of a tracer helps in understanding the various stages of the process, since it becomes a part and parcel of the system being that is investigated. So let us discuss about how tracer is used in the hydrological cycle and the groundwater cycle. As we know, groundwater forms a part of the hydrological cycle. You can see in the figure. So in the groundwater cycle, water from precipitation or from the surface water seeps into the ground, and then it reaches to the layers like the aquifers, the confined and unconfined aquifers of the earth crust, where it is stored. From the aquifer, the water is removed either naturally or artificially. In nature, the removal occurs through the springs and the subsurface flow, which may again emerge on the surface as base flow like lakes or rivers or coastal aquifers as a discharge into the sea. Pumping the water from the wells for agriculture or other needs is like artificial removal. Now the total volume of water in the cycle remains constant, and hence it is intensive use of the groundwater calls for an assessment of the groundwater reservoir and also the variations in the storage in natural and also in the artificial conditions. This can be done through the collection of accurate and comprehensive data from the reservoirs. So the general groundwater problems which we have are exploration of groundwater and location of the well sites, and the estimation of infiltration of rain and the groundwater recharge rates, measurement of groundwater velocity and direction, and measurement of the base flow, and also determination of the age of the groundwater, that means the residence time of the groundwater, and finally the determination of the aquifer parameters such as the porosity and the permeability. So in this we will discuss about the advantage of using the tracers to determine few parameters of the groundwater or the hydrological flow. So let us discuss about the properties of tracers that we use for groundwater studies. Generally, we have different types of tracers which are being used in finding in both the groundwater and the oil and gas exploration. So when it comes to the groundwater, we see a tracer should always follow the movements of the water as close as possible. Like it should not flow away and get away or get stuck somewhere. See, it is flowing here along with the water flow. So it should be the first property, and it should be easily detectable. That means when you add a tracer into the water, it should you have to, it can be identified easily. It should not mix along with the other ingredients and then vanish, and it should not change the hydraulic characteristics of an aquifer. See, when you are adding the tracer, it should not disturb the flow or the hydraulic characteristics of any aquifer, and it should not be absorbed by the media also. So if you add some kind of a tracer, and it should not be absorbed directly by the water or any other content, and it should not naturally be present in larger concentrations, because larger concentration will disturb or pollute the whole area. And it should have low toxicity, like in case of radioactive material. And in addition, the radioactive traces also must satisfy few conditions, like they should be having a useful half-life, which means long enough for the duration for the experiment, but also short enough so that the radioactive contamination is minimum for a period of experiment. And this should not be a hazard to the person who is handling this. So when it comes to the type of tracers, we can see there are two different types. One is the conventional tracer, that is the dye kind of tracer, usually is a salt or some kind of colored tracer. And the second type is isotope tracer. In general, isotope tracers are like radioactive materials such as tritium H3, the radiocarbon C14, and silica or the silicon Sa32. And we also have some stable environment isotopes such as deuterium, the oxygen 18, and the artificial radioactive isotopes such as H3, Na24, chromium 51, cobalt 50, bromine 82, iodine 131, etc. So we'll be discussing some of the merits and demerits of these different tracers. Of all the environmental or the conventional tracers that are available, dyes can be detected in very low concentration. So when you are adding the dye, so you can add a little and then you can identify. But the problem is they are subjected to the absorption. So after going for some distance, these dyes will be absorbed by the medium, or their detection sensitivity depends on the pH of the water also. Say something like chlorine anions, the sodium chloride or the ammonium chloride are excellent tracers, but actually when they are used in, they are used limited due to the relatively high natural concentrations, and the isotopic traces can be detected in much smaller concentration than in the conventional traces. As the anions are less absorbed than the cations, all the useful radioisotopes are induced into the anionic form by making use of the proper chemical complex. It is something like a chelated metallic compound of EDTA. EDTA means ethylene diamine tetraacetic acid. So we are discussing only about the introduction now. Then in the coming videos we'll go for a detailed definition of the use of the radioactive traces and their infiltration and recharge measurements also. Thank you.